Most engines don't fail because of poor engineering. They fail because wear accumulates in places owners never monitor. In Japan, taxi fleets and industrial operators routinely push engines beyond 1 million kilometers using a maintenance philosophy rarely applied elsewhere. It's not a miracle product or secret additive. It's a system of wear control. And it works. Number 1. Stop treating oil changes as intervals. Western maintenance culture treats oil changes as calendar or mileage events. Japanese long-life engine practice treats oil as a continuously monitored control system. Oil does not suddenly fail at a specific distance. It slowly loses its ability to suspend contaminants, neutralize acids, and maintain film strength under heat and load. Two engines traveling the same distance can degrade oil at completely different rates, depending on combustion efficiency, blow-by volume, fuel dilution, and thermal stability. This is why fixed oil change intervals are fundamentally unreliable for extreme mileage. Japanese fleets routinely analyze used oil and adjust change timing based on viscosity shear, insoluble content, oxidation, and dilution trends. Oil is replaced when its protective margin narrows, not when a number is reached. Engines that survive to 1 million kilometers do so because oil is never allowed to lose control. Number 2. Control blow-by, or everything else fails. Most engines do not die because oil wears out. They die because oil becomes contaminated faster than expected. The dominant source of contamination is blow-by. Every combustion event that slips past the rings introduces fuel vapor, moisture, soot, and acidic compounds into the crankcase. Over time, these overwhelm the oil's additive package and accelerate bearing and cylinder wear. Japanese long-life engines survive because crankcase ventilation is treated as a precision system. PCV flow behavior, separator efficiency, and pressure balance are maintained proactively. Weak separators are upgraded, baffles are cleaned, and valves are replaced preventively. A stable crankcase environment dramatically slows oil oxidation. Engines with perfect oil change discipline but poor blow-by control rarely reach high mileage. Engines with excellent crankcase control often do. Number 3. Warm-up is about oil temperature, not idling. One of the most persistent myths in engine longevity is that long cold idling reduces wear. In reality, it often increases it. Cold oil is thick and unevenly distributed. Extended idling delays proper ring sealing, increases fuel wash on cylinder walls, and starves the upper valve train of optimal lubrication. Japanese long-life practice focuses instead on controlled thermal expansion under light load. The engine is started, oil pressure is allowed to stabilize, and the vehicle is driven gently until oil temperature rises smoothly. Coolant temperature is secondary. Oil temperature determines bearing protection, ring sealing, and camshaft wear. Engines that consistently reach stable oil temperature without shock experience far less cumulative damage. Number 4. Eliminate micro overheating before it accumulates. Engines rarely fail from a single overheating event. They fail from thousands of localized heat spikes that never register on the gauge. Oil film collapses at hot spots long before bulk temperature appears abnormal. Ringlands, cylinder walls, and bearings experience momentary lubrication loss that slowly erodes surfaces. Japanese high-mileage engines survive because cooling systems are kept in precise thermal balance. Radiators are cleaned internally. Thermostats are selected for correct opening behavior. And coolant mixtures are optimized for heat transfer rather than freeze protection alone. Degraded coolant often looks acceptable while losing heat removal efficiency. This is why Japanese fleets flush cooling systems more aggressively than most service schedules recommend. Stable oil temperature is one of the strongest predictors of engine life. Number 5. Fuel quality is a mechanical variable. In Japanese maintenance philosophy, fuel quality is not a preference. It is a mechanical input. Injector spray pattern consistency directly affects combustion shape and local cylinder temperature. Small deviations in atomization alter heat distribution enough to accelerate oil breakdown and ring wear. Japanese fleets prioritize consistent fuel detergent quality, periodic injector cleaning, and intake cleanliness. Carbon buildup is understood not as a cosmetic issue, but as a combustion modifier. Engines that burn cleanly maintain more uniform temperatures, reduce oil oxidation, and protect internal surfaces far longer than engines that slowly accumulate deposits. Number 6. Avoid lugging, even if RPM is low. A common belief is that lower RPM always equals lower wear. Japanese endurance practice rejects this idea. High load at low RPM increases peak cylinder pressure, stresses bearings, worsens ring sealing, and destabilizes oil film thickness. Engines that are repeatedly lugged experience greater internal stress than engines operating at moderate RPM with lighter load. High mileage engines are kept within their efficiency band. Downshifting early and maintaining stable oil pressure reduces stress across rotating components. Engines that survive extreme mileage are rarely driven lazily. They are driven deliberately. Number 7. Seals are part of oil control. In many markets, seals are replaced only after leaks appear. In Japanese long-life practice, seals are treated as preventive wear items. Hardened seals introduce air, disrupt pressure balance, and accelerate oil oxidation. Small leaks often go unnoticed while quietly degrading oil performance. Valve cover seals, crank seals, and oil cooler seals are refreshed before failure in high-mileage engines. Maintaining oil containment is a core component of oil control. Oil that stays contained protects longer. Number 8. Data matters more than service history. A stamped service record does not predict engine life. Measured trends do. Japanese fleet engines are monitored using compression balance, oil pressure behavior, fuel trim trends, and blow-by indicators. Problems are detected tens of thousands of kilometers before symptoms appear. Engines almost always warn before failure. Longevity depends on noticing early. Number 9. Clean engines run cooler and last longer. Japanese mechanics keep engines clean for functional reasons, not aesthetics. Dirt traps heat, hides leaks, and accelerates electrical degradation. A clean engine reveals issues early and prevents external insulation that raises component temperatures. Engine cleanliness is part of thermal control. Number 10. The real Japanese trick is consistency. The final and most important principle is consistency. The same oil type, the same warm-up behavior, the same inspection routines applied relentlessly. Engines do not thrive on perfection. They thrive on predictability. Most engines fail not from neglect, but from inconsistent care.